Hello, everyone. My name is Robert, and I will be lecturing this introduction to quantum field theory. So let me start off by telling you what material we're going to cover. So I want to start off by developing an operator approach to quantum field theory. We are going to develop things in a very logical way and in a way that makes a lot of use of properties of free theories. I'm hoping this is going to give you a very good idea as to what a free quantum field is. Once we've done that, I'll show you a systematic way of quantizing, again, the free scalar field. And this is going to be called canonical quantization. The benefit of this approach is that by building things up slowly, where we basically use simple logic and physics that we know, you have a good idea as to what's going on and how to interpret the results that we've obtained. But then canonical quantization is a more abstract recipe. We'll use that and we'll recover the results that we obtained in a very straightforward way. The benefit of canonical quantization, though, is that it holds also for interacting theories. Once we've done canonical quantization, I'll then introduce you to a path integral quantization of quantum fields. And then we'll start to study interactions properly. I'll develop Feynman diagrams so that you will know how to derive Feynman diagrams yourself and how to use Feynman diagrams to evaluate various physical processes. This inevitably leads to ultraviolet divergences and to the topic of renormalization. So we'll develop renormalization in some detail. And I want to really develop Ken Wilson's thinking about renormalization and the renormalization group. And where you'll get to in this course is I'm hoping by the end of the course, you should be able to calculate meter functions and anomalous dimensions. These tell you, for example, how the coupling constant of quantum field theory changes as you vary the energy scale. So that's what we're going to try to do in the course. Maybe just one more comment. It's all scalar fields. So I'm developing quantum field theory just for a scalar field. I won't have dealt with fields with spins, so things like fermions and gauge fields, but we will know how to renormalize and how to think about quantum field theory. So for me, I prefer doing everything in detail for the scalar field, and then you can branch out and study other fields as another exercise and an application of what you've learned. How am I going to test you in this course? Well, every week there will be problems that I want you to answer and submit to me. I want you to submit them in the form of a LaTeX file. You're going to have to learn to use LaTeX. When you write papers, you use LaTeX before, so you'll produce a LaTeX document that you'll submit to a journal and to the archive. And you'll also be writing your thesis in LaTeX. So it's well worth learning LaTeX. This is a skill that you really should have. So send me a PDF file which has got your homework in it. The final exam for the course will be a take-home exam. I typically will give you something like 3 weeks to answer the exam. It's got 5 questions. I think they are relatively challenging. I've tried to think of problems that weren't solved yet in the literature. So calculating some beta functions and anomalous dimensions for Lagrangians that I dreamed up. And I think you'll learn something from the exam and you should enjoy the exam. I finally want to make one more comment. So why have I decided to record these lectures and make the recording available? Well, for many of you, you're not just learning new physics. You're also learning a new language. You're learning English. And if you want to stay in science, it's extremely important that you understand English, because that is the language of the international science community. It must be very hard. I am trying to learn Chinese now, and I find it very hard. So I imagine that you are finding it very hard to learn English. But be brave. Try to speak up in English. If you've got any questions, don't be shy to ask me. And if it takes you a while to get your question out, or you're struggling to find the right words, that's no problem. We've got time. So take your time. And if I give you an answer that you perhaps didn't catch because I spoke too quickly, don't feel shy to tell me to repeat the answer and to talk a little bit more slowly. I'll be very happy to do so. So in this course, I hope you're going to find it exciting. I hope it's going to be challenging. Any good course should be challenging. I hope you're going to learn lots of physics. And I also hope that you're going to learn some English. It's such a wonderful subject. So let's start learning it together.